Okay, so now we're doing our specific heat exercise. We've weighed the masses. Our first specimen is going to be iron, Fe, okay? So that's your first data sheet. Put iron, and you've got the masses of the iron specimen. You've got the water in the calorimeter cup, which is over here. And what I've done is put a thermometer from the calorimeter cup into the left temperature meter. The right temperature meter is measuring the specimen, the hot specimen. So what we're going to do is just monitor the temperature for about 4 minutes beforehand. So I've got my timer. We're going to put down our first reading. So you can see 18.9 and 100.1 degrees Celsius. So what we're going to wait is 1 more minute, and we're going to measure the temperature again. So just wait. Oops. It's the bottom number here. This is called, the method we're using is using the line of mixing. Because we have heat transfer, to get a better gauge of the heat transfer, we have to track the temperature over a 20-minute period. So we're coming up on 1 minute. So we're going to take the data again. I mean, it's not going to change that much. It just in case. Okay, we've got 18.9 and 100.0. It's moving around a little bit. I probably should, maybe this thermometer probably got pulled up a little bit. Okay. So we're going to wait till the bottom hits 2 minutes, and we're going to take another set of data. Now again, this is the proper way to do it. I know it doesn't look like the temperatures are changing right now. I do have cold water in there, and it's about the same temperature. I tried to get as cold a water as I could. I probably could have put some ice cubes and let the ice cubes melt to get even colder. Because of the larger the sample, it's not as bad, but it's best to do specific heat exercises to try and make the water as below the final temperature as the equilibrium temperature is above. Okay, now we got to take another set. We're at the 2 minute mark, 18.9 and 100.2. Okay. We're going to take 2 more measurements, and then what I'm going to do is I'm going to transfer this specimen really quickly into my calorimeter cup. I'm going to open up that black lid, and as fast as I can, there's a glare, transfer it in. Now, I'm going to try and not transfer any water with me. Water has a very high specific heat, but there's not much I can do. There's going to be some water that's transferred with me, and it's going to be hot, so that's going to tend to make the specific heat value a little higher. However, because of the heat transfer to the room, it probably negates that a little bit. Okay, now we're coming up on 3 minutes. We've got 18.9, and the thing I'm sorry, the thermocouple keeps moving out of the water. That's why it's moving up. It's 100.2. I can see it moving. It keeps like pulling up out of the water. I don't know. The bubbles are making it move to the surface, so I'm trying to push it down. Okay. So here's the timer. We're almost to 4 minutes. Now, once I transfer it in, we're going to take immediately, as fast as we can, take a value. The temperature of the combined system is going to go up fairly quickly. Okay, so this is the last measurement we're going to take before we dunk the sample into the calorimeter cup. 4 minutes. And again, 18.9. So there's no change whatsoever in the sample temperature beforehand. So the sample temperature before insertion is going to be 18.9. So what I'm going to do is, I don't need this thermometer anymore because the sample is no longer going to be in the hot water. So at the 5-minute mark, I'm watching, I'm at 4:23 right now. I am going to transfer my specimen into this cup. And then what we're going to do is take a reading of the temperature at that exact moment. So we've got 15 to 10, okay, almost there. So I'm going to get ready. Open up my cup. Shake off the water, and in it goes. Okay, so temperature is 20.7 at insertion. And you can see it's going up, and it'll go up for quite a while. Every 30 seconds, we're going to take a measurement now for a little bit of time. So, I don't know if I can put that. 5 minutes and 30 seconds, we're going to take another measurement of the temperature. 27.0. And again, you can see it's going up. The question is, when is it at its equilibrium temperature? It actually never quite reaches it, because once it goes in there, heat starts transferring out to the room. Even though I've got it closed, you still got some heat transfer going on. So again, in 5 more seconds, we're going to take another data point. 29.4. And it'll keep going up for a little bit. And then it'll level off a little bit and start to go down. And that indicates that it's already reached its equilibrium temperature, and I'm going to turn off the water right now so I don't have to hear it moving. Okay, so 6:30 is coming up. .4. So from 5 to 5:30, it went up close to 6 degrees. Then it went up another 2.4. Now it's only going up by 1. So you can see that the rate of heating, or the rate of the temperature rise, is lowering. And you can be able to see that from your graph. Okay, again, here's the time. Yeah, 30.8. So this time it only went up by 0.4 degrees. And we're going to take just one more 30 seconds, and then after that, we'll take them every 1 minute for the next, I guess, 13 minutes. So I think what I'm going to do is I'm going to try and set this up so you can see both of them at the same time, so I don't have to keep moving this up. 31.0 degrees. Up on something. So one more 30-second measurement, and then see if I can find something. Okay, we're almost to 8 minutes. So after this measurement, we're going to wait till 9 minutes to take the next data point, 31.0, so it hasn't changed. Eventually, it'll probably start going downwards. And now that I have a minute, I'm going to go wandering around for something to prop up my timer with, so I don't have to keep showing it to you. Okay. Let's see if... No, I got to move it up on a little plate. Okay, I've got 30 seconds to run and find something to put it on. It's getting there. Well, that's pretty good. Okay, so we're almost ready to take our next measurement. So this will be the 9-minute measurement. Okay, what's it say, 31.0? And again, it hasn't changed. So it seems like it's leveled off. It doesn't mean that this is the equilibrium temperature. I'm sorry, my paper was underneath it. How did I have it up there? All right. Voila. Okay, now you can see both of them. So I can just let it go and let you guys take the data yourself. You just have to pay attention. Every minute you've got to take the temperature reading. Now, in real life, scientists who do this for a living would actually have this attached to a computer, and they would take more than every minute. Oh, wait, 31.0. We're taking it by hand. This is the way it's been done for hundreds of years before the advent of the computer, of course. That was the 10-minute mark, so now we've got 10 more measurements to take. Ooh. So now you can see it's just dropping. And over the next hour, it's going to get lower and lower until it'll go to room temperature again. But we're not going to wait that long. Ideally, we could. However, that would be sort of monotonous. Okay, you can see that your measurement now is 30.9. That's the 11-minute mark. Okay, we're almost up to the 12-minute mark. I'm going to stop and run this again. It takes a long time to load this up onto my iPad, so I'm going to stop it after this measurement and then redo it. So now it's 30.8 is the 12-minute mark.